My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 613. In this lecture, we will try to understand data augmentation in deep learning. Data augmentation, the word augmentation basically means adding some new stuff. In lot of visual tasks, you want your models, your convolutional models, CNN models to be robust to things like that rotation or angular changes or scale or cropping of images, etc. So what we do here, imagine for a given an image, let me say I have an image, isn't it? This is given an image. Let's assume this is my input image, and let's assume this is my CNN. I can say this is my CNN model, isn't it? Instead of just giving a single image as an input, what I do here, I augment my data. That is important. Instead of just giving single image as an input, what I do here, I augment my data. Let's assume my initial data set is set of xi comma yi. A simple classification task like MNIST, isn't it? Let's assume this is my x1. This is my first image. Let me assume this is my x1. What is my x1? X1 is my first image. So I create new data set. What is my new data set? That is just let me take this image. My initial data set is xi comma yi. My d dash is xij comma yi, such that for each x1 I will create new images. I will call these images, just see, for each x1 here. This for x1 image I created x11, x12, x13, x14, x15, x16, x17, x18, x19. This is input image, capital D. We are creating these new images for this particular x1, isn't it? Otherwise, let me go back to our original data set which we discussing about this 6, isn't it? Here my x1 is, this is my x1. In this case this image 6 is x1. I will create new images. I will call these images as, just see, my capital D dash is xij comma yi. For each x1 I will create new images. What are my new images? Just see, by this x11, x12, x13, x14, x15, so on and so forth. I am creating lots of images. For every xi here, we are creating bunch of new images. How can I create these images? I am doing simple transformation. Here this 6, what is my input? My input is 6. On that 6 I am applying simple transformations. What are the I am rotating this 6. Just see, here I am rotating this 6, little bit rotating 6. I am slightly rotating it, isn't it? I am slightly rotating it because if I rotate it completely, it will become 9. So I don't want to do that, isn't it? So I rotate 6 a little. I add some noise. Just see, there are images for which I am adding noise 6, adding some noise, same 6, but I have added some noise. Some of the operations that we do, things like flipping. They say this one, flipping an image. Just you are flipping this image, isn't it? Flipping an image may not write. Flipping an image may not write for this particular 6, isn't it? But in some cases like faces, but it is appropriate for faces. Flipping is appropriate for faces. Whether the face is like this, whether the face is like this or like this, isn't it? You flip the face, it becomes like this. If you flip first image, you will get the second image, isn't it? It becomes like this, isn't it? Whether the face is like this or like this, it is still a face, isn't it? This is called flip operation. So you end up doing lot of operations like flip. I can say you can do lot of operations like just operations like flip. You can say horizontal shift, vertical shift, rotation, isn't it? There are different operations. So shift operation, flip operation. We can do rotation operations. We are rotating 6 a little right. We can also zoom operate. You can apply zoom operation, zoom in. You can apply zoom operations. There is something like zoom in, zoom out. Here the 6 zoom, if apply zoom operation, you can make 6 as a larger, even you can make 6 as smaller, isn't it? Yet that may be zoomed in, that may be zoomed out, and zoomed in and rotation. You can apply both operations, zooming as well as rotation, and I can combine lot of operations. I can do rotate plus zoom. I can do vertical shift plus zoom. I can do all of them. There is also something called shear operation, isn't it? Shear basically means if you have an image, if you shear means what? This is shear operation. You see, your shear may be along, this is original image, isn't it? This shear in x-axis, this is shear in y direction, isn't it? Shear is something like stretching one axis by keeping other axis same, isn't it? Shear is nothing but stretching one axis by keeping other axis same. Shear can be thought of as stretching stretch operation. By the way, when we create x11, what is the label? Just see, when you create, I am creating here. Just see, my original image is x1, for which I am creating x11. This is x11, this is x12, x13, x14, x15, so on and so forth. For this particular input image x1, label is 6. For all the newly created images, by applying different transformation, for all those images your label is same, isn't it? That's what it says, isn't it? You provide for you have to create y, you have to create yi. For x11 you have to create yi. For this x1, what is your y1? 6. This is y, for corresponding y is, for all the y means label, corresponding yi's, isn't it? When you are creating x11, what is the label? What is the label you provide to that? Yi will be the same, that is same 6. For this xi is also same 6, yi is also same 6, yi will be 6. All the images, all the x points label is 6 only. So what am I doing here is, for every data point in my original data set, I am augmenting my, what am I doing? I am augmenting, I can say I am augmenting my data set. I will keep the original one also, but in addition to it, I am augmenting, or I am adding new images to my data set by performing a bunch of operations like flip, zoom, shear, horizontal shift, vertical shift, so on, isn't it? You might wonder why are they useful? Why are we doing this? What is why is the data augmentation is useful? That's an important question. So first thing, you get lot of, what is the purpose? You can have lot of invariances. You can have lot of invariances, isn't it? Because you are explicitly performing rotation, which means you can get invariances. We have seen shift invariances, isn't it? We have seen shift invariances. Let me highlight this one, otherwise shift invariances, we learned about shift invariance when we read about max pooling. Let me say like this: we have seen shift invariances when we learn about max pooling. When we learn about max pooling, we said it creates a shift invariance. I request all of you to go through max pooling. By doing data augmentation, we can get any invariance. I can create about, I can get any invariance I can care about, isn't it? I can get rotational invariance, I can get zoom invariance, isn't it? I can get shear invariance. It creates shift invariance, isn't it? By doing data augmentation, we can get any invariances. We can get rotational invariance, we can get zoom invariance, I can get shear invariance. So I can get invariances, which means my output does not change, isn't it? What is the invariance? Invariance means my output does not change when the input changes slightly. I can also get noise invariance, isn't it? Invariance basically means input. Invariance basically means input to output mapping. Input to output mapping does not change. Input to output mapping does not change if input changes slightly. That's what an invariance means. Second, if you have a small data set, you can create much larger data set which is also relevant, isn't it? If you have let's say 1000 images data set, by applying all these invariance operations, I can create 10,000 image data set easily by performing all these operations one after the other. See here, from one image, just see here, from one image with bunch of operations, I created 5 into 4 20 images. Just see, from single image 6, we created 20 images by performing all these operations, all the operations like rotation, shifting, zooming, horizontal shift, vertical shift, adding noise, all these operations, isn't it? See here, for one image with bunch of operations, we created 20 images, isn't it? So you can augment your small data set that you might have to create large data set. Means by augmenting new images, you can convert small data sets into large data sets. Since you are introducing invariances in the data set, the model that you train, the connect models that you train becomes invariant to invariant. It will become invariant to all the transformations that you have introduced to the data set. And data augmentation is very by connet models that you train becomes invariant by data augmentation. I can say it's a very popular technique. It is very popular technique, especially for image data sets, because especially in images, especially in connets, we don't do as much as in multi-layer perceptrons. We do lot of this in convolutional neural networks. See, CNNs mostly operate, convolutional neural networks mostly operate on images, images, isn't it? Images that we want. Actually, as CNN operates on images, this is specially applicable for convets, isn't it? Where you can see the invariances, and we typically tend to have the problem of small data set which we want to convert into large data sets. So data augmentation is something that we will use a lot. We will discuss how to perform all these operations in one line of code in Keras. I will show it to you when we see one of the running example later in this chapter. So all the concepts that we are learning, we will see code for it in future classes. Just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.